In lesson 3.8, we're going to start looking at using our distributive property to simplify expressions in problem-solving situations. So our distributive property, the sketch note, be able to kind of explain this as well, is when we have a factor outside of two addends, combining, and they're in parentheses. So A would hop the fence, and when it hops the fence, it's distributing itself to both B and C here. When we distribute, we are multiplying. So A hops the fence, multiplies itself to B, and it goes to the C. But we keep the same operation, the addition sign here. So A times B plus A times C. Let's look at some examples, but we'll first look at some the key concepts of our vocabulary that we're dealing with. So we have our distributive property, 8 times 4 plus 6. And they leave the multiplication, that x there, but we don't need that. It always doesn't have to have the x because it could look like a variable. So 8 distributes itself to the 4, so that'd be like saying 8 times 4, plus we keep the same sign that is here. That addition sign stays. And so then we distribute the 8 to the 6, and so that'd be like saying 8 times 6. Same idea with 7 times, in parentheses, 6 minus 2. So we distribute the 7, so 7 goes to the 6, so that'd be 7 times 6, and 7 times the 2. Now, this is where most people make a mistake, and they don't remember about the inside operation, that subtraction sign. I keep the sign that is here for in between the two factors that are being multiplied. So 7 times 6 minus, because of the subtraction sign here, minus, and then in parentheses 7 times 2. Alright, now in algebraic terms, this is exactly like what I just showed in my sketch note. So that would be like saying A times B plus A times C. Or if it was a subtraction sign in the parentheses, that'd be A times B minus A times C. The operation just stays in the problem here. Alright, let's look at our first example. So we distribute to simplify, use a distributive property to simplify 5 times 47. Now 47, and we could multiply this. We could say, well, 47 times 5 to, just multiply this out. However, we can also do this a lot easier by breaking up what we know about 47. And 47 can be thought of as 40 plus 7. So I can write that as a distributive, or using a distributive property by saying 5 times 40, and that would be 200. And 5 times 7 is 35. And so when I add those two products together, 200 plus 35, I get 235. Why that works is exactly how, as I was talking through, saying 5 times 47 is breaking up to say 5 times 40 plus, let's write that as a 0, 5 times 40 and the 7. 40 plus, let's actually make that look a little bit better. Alright, 40 plus 7 makes up our 47. 40 plus 7 make up our 47, so 5 times 40, because I'm distributing the 5 to the 40, and I'm distributing the 5 to the 7. 5 times 40, and we're going to use the distributive property. Distributive property, so 5 times 40 is 200, and 5 times 7 is 35. We add those two together, and we still get our 235. Alright, now we're going to do a quick check. You pause and break this up, and then come back and we'll work through it. Alright, so we should have written this as 5, and this is 5 times 68, but I can rewrite that to say 5 times 60 plus 8, right? Because 60 plus 8 make up our 68. So I distribute my 5 to both the 60 and to the 8. And 5 times 60, well, I have that 0 there, so I can just think of it as 5 times 6, is 30, but then I add that 0, so I have 300. And 5 times 8 is 40. And so now I just add those two add-ins together, and I get 340. All right, for our next example, a student bought 4 tickets that cost $5.50. What's the total cost of the tickets? Well, we could actually, we could write this out and say 5.50 times 4, but we could use our distributive property to do this as well, and probably do it mentally too. So 4, if I break up 5.50, I'm going to break that up as saying it is, $5 plus 50 cents. Because 5.50 would be like saying, $5, and we have our 50 cents. Using our distributive property, we're going to multiply this. 4 times 5, well, that's going to be 20. And since we're talking money, we keep our decimal and our extra zeros. And 4 times 50 cents, well, we know that 4 quarters make $1. 2 quarters is 50 cents. So if I have 4 of them, or 4 sets of 50, then it's going to be $2. Now I've got $20 plus $2, so I put those together, and I end up with our $22 total. And we'll put our decimal in zeros. So it's a lot easier to break up our numbers like that. Alright, let's do another quick check. A local bookstore charges $2.80 for each book used. What is the charge for 5 books? So same idea that we just did for example 2. Break up your $2.80 and use your distributive property. Go ahead and pause and work through it, and then check back in a second. Alright, so what you should have done is, as you broke up your $2.80, that'd be like saying $2 plus 80 cents. If we break that up, we bought 5 of them, so I put my 5 on the outside. We distribute, saying 5 times 2, and that's $2, so it's going to be $10, plus, and I know that 5 times 80 is going to be 40, but since I'm dealing with money, 80 cents times 5, well, that's going to be $4. I add those two together, and I get $14. Why that works, and we could check that to say, always, check your work in the end. We could say, well, 280 times 5, we multiply that. 5 times 0 is 0, 5 times 8 is 40, put a 0 down, carry our 4, 5 times 2 is 10, plus the 4 is 14. I've got 2 numbers to the right of the decimal in my problem. So my answer, I need to move my decimal over twice, and I get $14. Alright, if you are still with me at our notes at this point, you get a little extra, and we want to use our distributive property to break up to expressions. So if I were to say, use the distributive property form by finding, or put in the distributive form by finding a factor. We're not solving it, we're just breaking it up. So if I have 24 plus 12, well, I need to think of what 2 factors make up 24, or what factor makes up 24 and 12. What do they share in common? And usually you want to look at what is the greatest one. And so if I think of, well, 24 and 12, they each share a 12. So if I factored out a 12, well, what times 12 makes up 24? Well, 2. And if I factored out a 12 from 12, that's going to be 1. And I keep the same operation. So 12 outside, so I would distribute my 12 to my 2 and distribute my 12 to my 1, and I'm going to end up with 24 plus 12. And of course, we could check that and say, 12 times 2 is 24, 12 times 1 is 12. We add that together, we'll get 36. If we added 24 plus 12 here, we're going to get 36. This is exactly what we're looking for when we say, put in distributive form, or distributive property form by finding a factor. Alright, and 32 minus 28. Same idea. Well, we think of what factor do they share in common. Well, 32 and 28, they each, they're both even, so we could say 2. But we could also say, well, they each share 4, because I know that if I factored a 4 out of 32, I get 8, and if I factor a 4 out of 28, I get 7. I keep the same operation sign here. So 4 times 8 is going to give me my 32, and 4 times 7 is my 28. So if I distributed this, I'd end up with the same value here of 32 minus 28. All right, so this would be if you were asked to put in the distributive form by finding a factor. That is the end of lesson